Alright, so I'm looking at Day 2, 5.3, Graphs of Rational Functions. This is an extension of Day 1 in where we're not only finding the asymptotes of our graphs, but we're actually going to look at the behavior of our graph around those asymptotes. Alright, now, as you recall, example 1 here, we have y equals 4 divided by x minus 3. The first thing I'm looking at is a vertical asymptote. Now these are our most interesting things. Where different things can happen. Now, in terms of our denominator, that's what we're looking at here. X equals 3 would give us a denominator of 0. Doesn't affect the numerator, so there's no hole. So we do have a vertical asymptote at x equals 3. Horizontal asymptote. Again, the degree of our denominator is higher than our numerator, and so we have a horizontal asymptote at y equals 0. Now, here's a concept. We want to know what is going on with our graph at our vertical asymptote. And you'll see how the horizontal asymptote, it gets taken care of when we graph this. So what we're going to do is we're going to find a limit. And we're going to find out what happens as x approaches 3. And from both sides of the graph. Because remember, vertical asymptote is a up and down line. So we want to know what happens when we come from the left and what happens when we come from the right of that asymptote. Because we don't cross it. That's the whole point of an asymptote. Alright, so from the left, I put a little negative sign. Alright, so I have my graph 4. There's our function 4 divided by x minus 3. I'm also going to find out what happens to this graph as x approaches 3, but from the right-hand side. So to denote the right-hand side, I put a plus sign. And again, here's my function. Now, the limits are going to work a little bit differently here than they did last time. Alright, so now the top. It's a 4. What I want to know is it's going to be a positive number. Now the bottom, if I plug in a 3, this thing is going to be 0. And again, you can't divide by 0, but again, we're doing limits, a little bit different. What happens to this just before it hits 0? Well, if I'm approaching 3 from the left-hand side, so you're looking at numbers like 2, 1, 0, I get really close to 3. Say, for instance, 2. Well, 2 minus 3 is a negative number. So before this denominator hits 0, it's going to be negative until it hits, well, I can't hit it because it's a vertical asymptote. So now, if I take a positive number and divide it by a very, 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 very small negative number, I get negative infinity. Alright, now to do the limit as we approach 3 from the right-hand side. Again, our numerator is going to be a positive number. Our denominator eventually will be 0, but what I want to know is what happens just before it would get to 0. Well, if I'm approaching 3 from the right-hand side, so numbers like 4, 5, 6, well, 4 minus 3 is positive. So before our denominator becomes 0, it would be positive if you're approaching from the right-hand side. And so now to figure out my limit, if I have a positive number divided by 0 plus, which means a very, very, very small positive number, that's going to be positive infinity. Now, how does that help us graph things? Well, I'm going to draw in my asymptotes. So first, I have x equals 3. There's our vertical asymptote right there. Alright, we also have a horizontal asymptote at 0. So I'll just draw right along our x-axis. So there's our two asymptotes. And now what I can do is draw in the graph with our information. Because what it's telling me is that if I approach 3 from the left-hand side, I got to go down to negative infinity. We'll see how the horizontal asymptote comes into play now. I cannot go down to negative infinity without crossing that asymptote. So my graph won't start up here, it'll actually be down here. And so as I approach 3 from the left-hand side, I'm going down to negative infinity. And then the graph has to keep going and approach our horizontal asymptote. As I approach 3 from the right-hand side, so I'm coming this way, I'm going up to positive infinity. So again, I cannot be in this quadrant. I have to be up here because I can't go up to negative infinity because I crossed my horizontal asymptote. So as I approach 3 from the right-hand side, I'm off to infinity. And again, as I move to the right infinitely, I would be approaching my horizontal asymptote. And there's a sketch of our graph. Alright, now, we get to example 2. Again, same steps. I'm going to look at the vertical asymptotes first. Alright, so what do we have here? Denominator, a 3 would make it equal to 0. How does that look up top? Negative 2 times 3 is negative 6 plus 4. Not 0, so we do have a vertical asymptote at x equals 3 again. Alright, horizontal asymptote. When does, look at our degree, they're equal. So we have degree 1 on the numerator, degree 1 on the denominator. And so we divide their coefficients, so negative 2 divided by 1. Well, we have a horizontal asymptote at negative 2. Alright, y equals negative 2. Alright, so now I'm going to do the limits for our vertical asymptote. Alright, so I have the limit as x approaches 3 from the left-hand side. That's what that negative sign means. I'm going to write my function in here, negative 2x plus 4 divided by x minus 3. Alright, so we'll figure that one out. We'll also figure out our limit as x approaches 3 from the right-hand side. Again, I'm going to write my function down. Alright, so let's see what happens. On the top, if I plug in a 3, I get negative 2 times 3 is negative 6 plus 4. The numerator here is going to be a negative number. Alright, now I'm going to do the same thing with the denominator. If I plug a 3 in there, it will be 0, but just before it gets to 0, left of 3, a number like 2. 2 minus 3, it would be negative. I'd have it, so before it gets to 0, it's going to be a very small negative number. So now I have a negative number divided by a very, very, very small negative number. Negative divided by negative, I'm going to get positive infinity this time out. Alright, now I'm approaching from the right-hand side of 3. Again, the top, I plug in a 3, going to get a negative number. The bottom, this time, before it hits 0, well, a number right of 3 is like 4. 4 minus 3 is positives. So if I take a negative number and divide it by a very, very, very small positive number, that's what 0 plus means, I'm going to get to negative infinity. Alright, now sketching my graph. Again, I have a vertical asymptote at 3. We'll sketch that in. I have a horizontal asymptote at negative 2. So again, just a sketch. Alright. And again, our asymptotes, our limits for our asymptote, vertical asymptotes will tell us what the graph's doing. So again, as I'm approaching 3 from the left-hand side, I'm going up to infinity. Which means I can't be in this quadrant, I have to be up here. Because as I approach 3 from the left-hand side, I'm going up to infinity. And again, going this way, it must hug our horizontal asymptote. Alright, now using my other limit, as I approach 3 from the right-hand side, it goes to negative infinity. So I can't be in this quadrant, so I must be in this quadrant because I have to go downwards as I approach 3 from the right-hand side. And again, extending our graph, it must hug our horizontal asymptote. So again, we have to be able to find out where the vertical and horizontal asymptotes are, and then we're going to find out what the graph's doing at those spots using limits, both approaching the vertical asymptote from the right or the left-hand side and the right-hand side.